day! Welcome to my hi-fi audio channel. I'm Zhang Hanwen, an acoustic engineer. In our last episode, we discussed about the structure and characteristic of diode tube. In this episode, we're going to talk about the diode tube application half-wave rectifier and dual diode tube full-wave rectifier. And before we dive into the main topic, let's quickly explain what the alternating current is, aka AC. As you can see in the diagram, the green sine wave represents the waveform of AC power from an outlet. The y-axis shows AC voltage, and the x-axis represents time. The waveform of AC means the current regularly changes direction over time. In the upper half of the cycle, the current flows in one direction, and in the lower half, it flows in the opposite direction. AC typically operates at 60 Hz, which means the direction of the current changes approximately 60 cycles per second. In other words, with the 60 Hz AC, the current flows in one direction for the first 1/120 of a second, aka 1/120th, which is the positive half cycle, and in the opposite direction for the next 1/120 of a second, which is the negative half cycle. So, with 60 Hz AC, the current changes direction every 1/120 of a second. When 60 Hz AC passes through a single diode tube, the diode tube only conducts in one direction. Hence, the AC current conducts for 1/120 of a second, then is blocked for the next 1/120 of a second. And then the current direction reverses and conducts again for 1/120 of a second. Keep continuing this pattern to form a pulsating DC. So the AC, which originally flows in both directions, becomes DC flowing in one direction after passing through a diode tube. This is the diode tube's function, rectification. Using a single diode tube to rectify AC results in a pulsating DC known as half-wave rectifier. What if we want AC to be rectified into continuous DC without interruptions? Now we need dual diode tube. Dual diode tube means we integrated two diode tube into one vacuum tube. Let's look at the symbols for dual diode tube. On the far left is a directly heated dual diode tube, and the filament is directly heated by the power. The two on the right are indirectly heated dual diode tubes, where the cathode is heated by the heater. These symbols differ due to their structural differences. Regardless of whether they are directly or indirectly heated, dual diode tube has two anodes and typically shares a single filament or a heater. Now, let's see how to use a dual diode tube for rectification. This diagram shows a 5U4G, a directly heated dual diode tube. First, we connect the AC power from the outlet, assuming AC 110 volts, to a transformer to step up the voltage as indicated by the red arrow. The stepped up voltage from the transformer's secondary coil is then connected to the two anodes of the dual diode tube, as indicated by the blue arrow. Every vacuum tube has its maximum voltage and current ratings. If the maximum rating is exceeded, vacuum tube will be damaged. For example, the 5U4G dual diode tube we use here can handle input voltages up to 450 volts and currents up to 225 milliamps. These maximum values can be found in the datasheet. Therefore, it's crucial to read the datasheet carefully before designing vacuum tube circuits. Alright, let's get back to our rectification circuit. We connect one set of AC 5 volts from the transformer to the filament of the dual diode tube for heating, indicated by the green arrow. Then, we take the DC output from the filament, indicated by the red arrow. At this point, we have rectified the AC into a continuous single-direction DC, known as full-wave rectifier. These are just basic discussion on diode tube. By the way, diode tube is also known as rectifier tube. I'm sure some of you might wonder about what the common rectifier tube available on the market. Here I list some common rectifier tube models for your reference. Common rectifier tube models include 5U4, 5AR4, 5R4, 5Y3, EZ80, EZ81, GZ34, GZ32, etc. These rectifier tubes are produced by different manufacturers worldwide. You can learn more about well-known vacuum tube brands in my first episode, The History of Vacuum Tubes and Famous Brands. Alright, our fascinating journey through vacuum tube and hi-fi audio has come to an end. Thank you all for watching. Please support me by liking, subscribing, and sharing. I will continue to produce more contents about vacuum tube and hi-fi audio. I'm Zhang Hanwen. I'll guide you through the wonderful world of vacuum tube and hi-fi audio.